Welcome to the Clojure Koans walkthrough number 14, Destructuring. So, we're going to take a look at what Clojure has to offer in terms of destructuring. So what is destructuring? Well, it's all about being able to extract values from a structure. So with just one assignment statement, you can pull out one or more values from a structure, and it may even be a complicated structure. So let's take a look at the first example. Destructuring is an arbiter. It breaks up arguments. So here we're seeing a function defined, an anonymous function, and now you have to look closely here, but it actually just has one parameter, but it expects that parameter to be a vector with two elements in it. And so here with this syntax, it's able to say that I want this one parameter to be a vector, and I would like to pull out the two values from it and assign them to the variables a and b. And then what this function is doing is simply returning back a string of b and a. And look here, this function is being called with one parameter here, this vector. And it's a vector of two elements, just like you see being passed here. So a will be foo and b will be bar. What do we expect in the return here? This is going to be a string with the b first, bar, and then the foo. There we go. Now let's see. So whether in function definitions. Let's see, our result here is this string. First comes love, then comes marriage, then comes Clojure with the baby carriage. And how did we produce this? Well, we've got an anonymous function and this vector being passed to it. This vector of 3 elements. So it's using destructuring to express this, that we're expecting the one argument to be a vector with 3 elements, and we're going to assign each of those elements to a variable here, a, b, and c. So what do we return? Looks like we need to return a string, and it will be pretty much just like this string, except for some parameters being used here. So the first one is a. This one is B, and that one is C. Nice. Okay, so destructuring probably saved us some lines of code, being able to just express this with one line here, one expression, and pull out those values. That's pretty powerful. But it's not only useful in function definitions. Here we see it's useful in let expressions. So what do we have here? A string. It says Rich Hickey, aka the Clojurer, aka Go Time, aka Macro Killer. Cool. So how did we make this? We've got a let statement. It's saying that this list is gonna have this kind of a structure where we're pulling out the first element and assigning it to first name. The second element we're assigning to this last name variable, and all the rest of whatever's in that sequence, we're assigning it to aliases. Just like you saw before with functions, we can use this ampersand character and then a variable name to assign all the rest to this sequence. So what do we need to return this nice string? Looks like we're going to have a string, and it's going to start out with the first name, and then a space, and then the last name. And for each of these aliases, we need to return aka, then the alias. So let's see, how might we do that? Maybe we can use a map. How about that? Let's say map some function over those aliases. So what do we want our function to do? How about we just make it as a string, and it says aka, and then the alias name. Oh yeah, we need to apply apply string to that. Yeah, that should do it. Okay, there's probably other ways to do it, but this is one. Cool. Now, let's see what else. You can regain the full argument if you like arguing. So this is producing a map. Let me just put this all on the screen. Okay. So original parts, it's got a vector. Named parts, it's got a map with two elements, first and last. So how did it do this? It's doing this destructuring assignment here, where given this vector with Stephen Hawking, two elements, a string Stephen and a string Hawking, and it's doing a destructuring assignment to this expression where we've got a vector with a first name, a last name, and then it's saying as full name. So this is a special keyword here. We can say as and then full name, and this entire vector will be assigned to full name. So let's see what we can do with that. So with this let statement or let expression, we need to build a map, and it's going to need to include original parts, which returns back probably just full name, right? That's the full expression we were given. And then it needs to return back named parts, and that's with the first being the first name that we extracted, and the last with the last name that we extracted. There you go. Cool. Thank you, Destructuring. Now, break up maps by key. We need to build this string, and here's our let statement with the destructuring bind. Oh, okay. So it looks like we're dealing with maps now. And oh yeah, by the way, these commas are just treated as white space. They're not really necessary. So anyway, we're dealing with this test address that was defined all the way up here on the top. The test address has a street address, a city, and a state. And it looks like they're pulling those elements out of the map using this destructuring bind. So with this kind of syntax, we're saying I want a street address variable, and it's going to come from this key, street address. So you say what the keyword is, but before that you declare the variable. So we're pulling out three values from the map: the street address, the city, and the state. So we'll assume those values have already been retrieved for us, and now we just need to return back some kind of a string. String starts with, I guess, the street address, and a comma, and a space, and the city, and a comma, and a space, and the state. Cool, there we go. So that was destructuring with a map. Now here's another way to write that, which is a little bit easier. So Clojure has another trick up its sleeve. Okay, I'm dealing with a map. So let's say I just want to list out all the keys I want to pull out. So here I'll use the keys keyword and then a vector with basically the list of the keys I want to pull out. So here we can say we want to pull out the street address. What else do we want to pull out? The city and the state. So these are going to be treated as keywords like that when fetching the values from the map. But then it's going to end up being assigned to a variable called state, for each one of these. So we can do the same thing, it looks like. Let me paste that in here. Cool. So that's another syntax. The only restriction is that your variable name must correspond to the key in the map. Whereas up here, we didn't have that restriction. If we wanted to say, we want to pull out the value of the city key, but the variable can be anything else. We could name it arbitrarily, and that works. But here, we're going to have a shorter way to say it, but with the restriction that the variable names must correspond to the keys, the key names. All right, all together now. So we were trying to build this string, and the blank here is looking like we need to write a function. So it's a function of 2 parameters, it looks like, this vector and then the test address. Cool, let's see if we can use some destructuring syntax to make this really easy. So let's create a function, and it's got 2 elements. It's got some kind of a vector. Let's just write that vector right here. It's got, let's say this is a first name and then a last name, Testerson. But after that, it's also got this map. And what do we want to pull out of there? Let's pull out the keys from that map. Again, the street address, city, and state. Cool, so that was pretty easy to pull out all those values. Now we can just return the same thing as before with the first name and last name added. Okay, so we've got a string we need to return, and we're going to put in there first the first name, comma, no, sorry, space, last name, comma, space, and the rest. Excellent. That one passed. So that's a taste of destructuring bind. So enjoy using this trick in your programs, and I'll see you in the next video.